Hey everyone, welcome back to the channel. So Spring Boot 4 just dropped, and I want to answer the one question I have been getting non-stop in the comments. Do I actually need to upgrade? Is this just a version number bump, or is Boot 4 a real deal? And the honest answer is, it is a real deal. Spring Boot 4 is probably the biggest structural change since Spring Boot 2 became Spring Boot 3. There are brand new features, things that got removed, and yes, some stuff that will break if you just blindly change the version number without reading the migration notes. But don't stress, that's exactly what this video is for. Here is what we will cover today. What actually changed, not just a list, but why it is changed and what it means for you. Real code examples for the big stuff like HTTP service clients and Jackson 3. A step by step migration checklist. 8 steps, do them in order. And a decision framework. So by the end of this video, you will know exactly when you should upgrade. Let's get into it. I'll try to keep this as practical as possible. No fluff, no fillers. Alright, let me set the scene. What you are looking at on the screen is the presentation we will be walking through today. I'll be clicking through slide by slide, so each piece of information appears right when I am talking about it, just like a live coding session, but for architecture decisions. For quick stats on the right side of the screen, Spring Boot 4 is the current stable release as of late 2025. You will need Java 17 at minimum, the same as Boot 3 actually. So if you're already on Boot 3, you are good on Java. There are 8 steps to migrate from Boot 3.5 to Boot 4. We will walk through every single one on slide 5. If you have a small microservice with standard dependencies, this whole migration is probably half a day of work. For larger apps, we will talk through exactly what drives the effort. Let's get into the actual content. First up, what's actually new. We have 8 headline changes in Spring Boot 4. I'll walk through each one. And for the big ones, HTTP service clients and Jackson 3, I'll go into real code detail. Feature 1 is modularization. This is the biggest structural change in Boot 4 and it's going to affect every single project that upgrades. Here is the analogy I want you to think about. Imagine you go to IKEA and instead of buying a kitchen set as one giant box, you now buy each individual part separately. The cabinet, the drawer, the handles. You only pay for and carry home exactly what you need. That's what modularization does to Spring Boot starters. In Spring Boot 3, when you added Spring Boot Starter Web to your project, it comes with a lot of stuff bundled together. In Boot 4, the same concept is now broken down into smaller, more focused modules, each one named Spring Boot and the technology. For example, Spring Boot Starter Web becomes Spring Boot Starter Web MVC. Flyway gets its own boot managed starter, Spring Boot Starter Flyway. Each technology also gets its own test starter. So instead of one giant Spring Boot starter test, you would use Spring Boot starter flyway test for flyway specific testing. So why does this matter? Because smaller modules mean faster startup time. Your app doesn't load code it doesn't use. Smaller artifact size. Your jar file is leaner. Fewer dependency conflicts. Each module has a clear purpose and boundary. Feature 2 is null safety with JSpecify. JSpecify is a standard set of null safety annotations. Spring Boot 4 now uses these annotations throughout the framework code. Think of it like road signs. JSpecify annotations are like a null ahead warning sign that your IDE and static analysis tools can read. Instead of finding out at 2 a.m. when something crashes in production, you find out at compile time. The main annotations you will see are at the rate nullable and at the rate non-null. Your IDE will highlight potential null issues as you type before you even run the code. Feature 3 is Java 17, 21 or 25. Spring Boot 4 still requires Java 17 at minimum, same as Spring Boot 3. So if you're already on Boot 3, you haven't lost anything here. But the big deal is Java 21 support. Let me quickly explain virtual threads because this is genuinely exciting. Traditional Java threads are expensive. Creating 1000 threads uses a lot of memory. Each one might consume nearly about 1 MB of RAM. Virtual threads introduced in Java 21 are super lightweight. You can create millions of them with almost no overhead. This means your web app can handle massively more concurrent requests without needing more servers. With Boot 4 and Java 21, you get virtual threads configured automatically. Zero changes to your application code. Just add one liner to your application properties, which is spring.threads.virtual.enabled equal to true. And Boot wires everything up. Your Tomcat threads, your JDBC connections, all virtualized. Feature 4 is HTTP service clients. This is one of my favorite new features in Boot 4. Let me explain the problem it solves first. Whenever your app needs to call an external REST API, say a payment API or a user service, you have to write a lot of boilerplate code with the REST template or web client. You write the URL headers, parse the response, and handle errors. HTTP service clients completely eliminates that boilerplate. Instead, you just define a Java interface like this using the at the rate HTTP exchange annotation. That's it. You don't write an implementation class. Spring Boot sees this interface and it actually creates the HTTP client for you with all the connection pooling, error handling, and serialization built in. If you have used Spring Data JPA before, where you write a repository interface and Spring creates the database queries for you. This is the exact same concept, but for REST API calls. Spring Boot injects the auto-generated implementation. Your code is clean, testable, and has zero boilerplate code. Feature 5 is API versioning. If you ever had to version a REST API, like supporting both API slash v1 slash users and API v2 slash users simultaneously, you know how messy it gets. Different teams solve it differently. URL paths, request headers, query params, etc. Spring Boot 4 adds framework level API versioning. You configure it once in the properties. Then in your controllers, you can specify which version a handler supports. Both handles routing the request to the right version. No custom interceptors, no duplicate URL and mappings. Feature 6 is OpenTelemetry Starter. OpenTelemetry is a standard for collecting observability data, traces, metrics, and logs from your application. Think of it as a universal standard that works with tools like Jagger, Zipkin, Datadog, Grafana, and dozens of others. Imagine you have a user clicking Buy Now in your app. That single click might trigger 5 microservices. With tracing enabled, you can see the full journey. Service A took 10 milliseconds, service B took 200 milliseconds, and that's where the slowdown is. In Boot 3, setting up tracing requires several dependencies and manual configuration. Boot 4 ships with a single starter, which is Spring Boot Starter Open Telemetry, and then you set your endpoint in properties. That's it. Every HTTP request your app receives now automatically generates a trace exported to your observability pattern. Feature 7 is Gradle 9 plus build updates. Gradle 9 is now fully supported. If you are using Maven, nothing changes here. If you are on Gradle, you can safely upgrade your Gradle wrapper to version 9. Also, if you generate a software bill of materials SBOM using the Cyclone DX plugin, which creates a manifest of all your dependencies for security scanning, you will need to upgrade that plugin to version 3.0 or higher. Feature 8 is Jackson 3 migration. Jackson is the JSON library that Spring Boot uses to convert Java objects to JSON and back. When you return an object from a REST controller, Jackson serializes it into JSON. When a request comes in with a JSON body, Jackson deserializes it into your Java object. Spring Boot 4 migrates from Jackson 2 to Jackson 3. The API is similar, but there is one breaking change: the package name. Jackson 2 package name is com.fasterxml.jackson and Jackson 3's package name is tools.jackson. So if you have a custom Jackson code in your project, custom serializers, object mapper configurations, annotation imports, those import statements will break and need updating. Don't worry, we will cover exactly how to handle this in the migration guide on slide 5. I want to zoom in on modularization because this is the change that will require the most hands-on work when you upgrade. Let me show you with a concrete example. A typical web application with a database migration tool called Flyway. So what is Flyway? Flyway is a data migration tool. Imagine you have a database with a users table. When your app evolves, you might need to add a new column, say email underscore verified. Flyway manages these changes with version controlled SQL scripts. When your app starts, Flyway runs any new migration scripts automatically, keeping your database schema in sync with your code. In Spring Boot 3, using Flyway looks like this in your pom.xml file. Notice the problems. Flyway is referenced directly from the Flyway vendor, so Boot doesn't manage its version. You have to check compatibility yourself every time you upgrade Boot. Spring Boot Starter Test is a massive catch-all. It pulls in JUnit 5, Mockito, AssertJ, test containers, Spring Test, Mock MVC, and much more, even if you only use half of these. Now here is the same setup in Spring Boot 4. The improvements. Flyway now has a boot managed starter. Boot controls the compatible version automatically. You will never have a version mismatch again. The test starter is now technology specific. Spring Boot Starter Flyway Test only pulls in what you need to test Flyway migrations and nothing extra. Important. You do not have to migrate all of your starters at once. Spring Boot 4 ships two classic starters for exactly this transition. Spring Boot Starter Classic and Spring Boot Starter Test Classic. These brings back the old Boot 3 class path. So you can upgrade the version first, get everything compiling, then gradually replace classic starters with precise ones. One technology per PR. Alright, let's do the full feature delta. What's in, what's out. I will reveal these in pairs so you can see the trade-offs. We have already covered the HTTP service clients, interface-driven REST. Love this feature. On the removed side, Undertow. Now let me explain what Undertow is for those who haven't used it. Undertow is a servlet container, the engine that actually receives HTTP requests and routes them to your Spring controllers. By default, Spring Boot uses Tomcat. Undertow was an alternative known for being very lightweight and fast in reactive, non-blocking scenarios. Boot 4 removes Undertow because it's now compatible with Servlet 6.1 specification that Boot 4 requires. If your app currently uses Undertow, you need to switch to Tomcat, the default or Jetty before you upgrade to Boot 4. To check if you are using Undertow, search for your pom.xml for Spring Boot Starter Undertow. If you see that, add it to your migration backlog first. API versioning is new. Already explained this on slide 2. On the removal side, it's a reactive Pulsar. Apache Pulsar is a messaging streaming platform similar to Kafka. It lets different services communicate by sending messages through a central broker. Boot 3 had auto configuration for Pulsar Reactive non-blocking client. In Boot 4, this auto configuration has been removed from Boot core and will need to be handled by a separate vendor managed dependency. If your app uses Reactive Pulsar and you are seeing it in your dependencies, check the Spring Pulsar project for updated migration instructions. OpenTelemetry Starter, already covered in slide 2, removed. Execute OpenTelemetry Starter, already covered in slide 2, removed executable Uber jar scripts. In Boot 3, you could create an executable jar, a single jar file that could be launched directly as a Unix Linux service with a built-in startup script embedded in the jar. This was a convenient way to run boot apps as a system services without a service manager. Boot 4 removes this embedded script support. The modern approach is to use your OS native service manager. This is the actual practice anyway. You get proper logging, restart policies, and dependency management for free. REST Test Client is a new test utility that gives you a fluent, readable API for testing REST endpoints in @Spring Boot tests. Spoke testing integration has been removed. Spoke is a testing framework written in Groovy. It's popular in some teams because it has a very readable given when then test structure and built-in mocking. Boot 3 had a Mockito test execution listener that integrated Spoke with Boot's test machinery. This has been removed in Boot 4 due to Groovy 5 compatibility gap. You can still use Spoke with Spring Boot 4. It's just the boot specific test execution listener that's gone. You will need to wire Spring you need to wire Spoke up manually or wait for an updated Spoke plus boot integration. Kotlin's serialization is now a first class starter if you're using Kotlin. It's Kotlin native serialization library, significantly faster than Jackson for Kotlin data classes and produces cleaner code. Spring Session for Hazelcast and MongoDB has been moved to vendor team ownership. Spring Session manages user sessions in distributed applications. So if you have multiple instances of your app running, they can all share session data through a central store like Redis, Hazelcast or MongoDB. The Hazelcast and MongoDB backends for Spring Session have been moved out of the boot core and will now be maintained by their respective communities. Added Redis observability and removed classic Uber jar loader. Redis observability means your Redis operations, cache reads, writes, pub/sub are now automatically traced via Micrometer. Zero configuration. You will see Redis call duration and errors in your Grafana or Datadog dashboard without adding a single line of code. Redis is an in-memory data store. It's most commonly used as a cache. So instead of hitting your database every time someone requests the same data, you store it in Redis and return it instantly. Redis calls is Observability of Redis calls is critical for catching slow cache operations. Mango added MongoDB health and removed property mapper.always method. MongoDB health checks now work without Spring Data MongoDB on the class path. Previously, you needed the full Spring Boot data and MongoDB starter just to get a health indicator. Property mapper.always method is an internal boot API change. If you haven't written custom boot auto configuration, this won't affect you. If you have, your IDE will flag the deprecation. Alright, this is the section most of you came for. Let me walk you through the 8-step migration path from Spring Boot 3.5 to Boot 4. Do these steps in order, don't skip ahead. Step 1. Land on Boot 3.5 first. Do not jump directly from Boot 3.2 or 3.3 to Boot 4. The recommended path is get to 3.5 first, resolve every deprecation warning, get your test suite fully green, then move to 4.0. Why? Because Boot 3.5 was designed as a stepping stone. Many of the APIs that are fully removed in Boot 4 were deprecated in Boot 3.5, with explicit will be removed in 4.0. Why? Because Boot 3.5 was designed as a stepping stone. Many of the APIs that are fully removed in Boot 4 were deprecated in Boot 3.5, with explicit will be removed in 4.0 messages. If you clear your deprecation warnings on 3.5, you have already done 40% of the Boot 4 migration. Step 2 is to bump to 4.0 plus, add classic starters. Now update your parent POM version. Then immediately add the classic starters to preserve your old class path. Now run your tests with classic starters. Your test suite should still pass. If anything breaks here, fix it before moving on. Steps 3 and 4 Dependencies and Jackson. Replace classic starters gradually. Now, one technology at a time. Replace the classic starters with the precise Boot 4 starters. Here is a handy mapping. Spring Boot Starter Web with Spring Boot Starter Web MVC. Spring Boot Starter Web with Spring Boot Starter Web Flux. Flyway Core. Spring Boot Starter Web with Spring Boot Starter Web MVC. Spring Boot Starter Web Flux remains unchanged. Flyway core to Spring Boot Starter Flyway. Spring Boot Starter test to Spring Boot Starter and the technology you want to test, the technology name, and then test. Spring Boot Starter security test. Spring Boot Starter Web to Spring Boot Starter Web MVC. Spring Boot Starter Web Flux remains unchanged. Flyway core to Spring Boot Starter Flyway. And for any test dependency, Spring Boot Starter test to Spring Boot Starter, the technology name, and then test. Springs to Spring Boot Starter security test. Do one technology per PR. Run tests after every change. This way, if something breaks, you know exactly which dependency caused it. Step 4 Handle Jackson 3, the tricky one. This is the most complex part of the migration for most teams. Quick stopgap. Buy yourself time with this property. Spring use Jackson 2 defaults equal to true. This tells boot to use Jackson 2 compatibility mode. Your existing code won't break immediately, but you must come back and fix this properly. It's deprecated. The proper fix is to update all Jackson 2 imports to Jackson 3 imports. Also update your application properties. Step 5 and 6 Packages and Properties. Two important package changes that you will need to update. Steps 5 and 6 Packages and Properties. Two important packages changes that you will need to update. Your ID will flag these as compiler errors. IntelliJ users just hit Alt plus Enter, import class, it will fix it automatically. Step 6 Update renamed properties. Run a global search in your application.properties and application.yml files for these renamed keys. I'd recommend doing a project-wide search for management.tracing and spring.dao to catch every instance. Steps 7 and 8 Tests and Build. Fix test configuration. Two test related changes to know. Change 1 @autoconfigure mock MVC is no longer automatic. Change 2 Replace Mockito test execution listener. Step 8 Update building tool. Gradle users upgrade to Gradle 9, fully supported in Spring Boot 4. Cyclone DX plugin users upgrade to version 3.0.0 or higher. Remove any classic Uberjar loader settings from your build config. After all 8 steps, run your full test suite. Fix anything that's broken. Deploy to a test environment and smoke test the key users flow. You are done. Let's bring it all together. Here is my simple traffic light framework for deciding when to upgrade. You should upgrade today. If you are starting a brand new project, always start on the latest stable release. Never start a greenfield project on Boot 3 if Boot 4 is available. You are already on Spring Boot 3.5 with Java 21. The upgrade is smooth from 3.5 and you will immediately benefit from Java 21 virtual threads. You need HTTP service clients or API versioning out of the box. These are Boot 4 exclusives. Boot 3 doesn't have them. You want open telemetry, tracing with zero configuration. The new starter makes this trivially easy. For a standard microservice on Boot 3.5, expect this migration to take about half a day, maybe less if you don't have heavy Jackson customization. The yellow light. You should plan a migration script You should plan a migration sprint if you are on boot 3.0 or 3.4. Don't just straight yellow light, plan it, then upgrade. You should plan a migration yellow light, plan it, then upgrade. You should plan a migration yellow light, plan it, then upgrade. You should plan a migration sprint if you are on boot 3.0 or 3.4. Don't just straight to 4.0. First upgrade to 3.5, resolve all deprecation warnings, then plan the 4.0 move as a separate piece of work. You have a large number of custom boot starters or heavy test infrastructure. Modularization means more remapping work, budget time for it. Your code base is deeply pinned to Jackson 2. Lots of custom serializes, object mapper beans, custom annotations. Use the Jackson 2 stop gap module with your migrate, but plan to fully remove it within the next sprint or two. You have a large team, coordinate the classic to precise starter, swap across branches carefully to avoid merge conflicts. For a large monolithic or a team with any many custom boot configurations, budget a full sprint of 1 to 2 weeks. Light. Fix blockers first. Hold off on boot 4 until you have resolved Undertow dependency. Boot 4 simply doesn't support Undertow. Switch to Tomcat or Jetty first. This is a hard blocker. Spoke testing framework. If your entire test suite is in Spoke with boot specific integration, wait for the Groovy 5 gap to be resolved or plan to migrate tests to JUnit first. Reactive Pulsar auto configuration. If you rely on Boot's built-in Pulsar reactive auto config, you will need to find an alternative approach first. For drivers. So when estimating how long your migration will take, four things drive the most effort. Custom starters to remap. Each custom boot starter needs to be mapped to the new modular equivalent. Jackson to depth. How many files import com.fasterxml.jackson? Grab your code base to find out. Boot 3.x deprecation debt. Ignored deprecation warnings from boot 3 become compiler errors in boot 4. Test infrastructure complexity. How many custom at the rate test configuration classes, custom test runners, or boot test utilities you are using? Before we wrap up, let me give you all the links you need to go deeper. These are all the links. And if you want to try Boot 4 on a new project right now, just add this to your dependency and you're good to go. Alright, that's the full Spring Boot 4 breakdown. Let's quickly recap what we covered. The 8 headline features, especially modularization, HTTP service clients, and Jackson 3. The full feature delta, what's new, what's gone, and why. The 8-step migration guide for Spring Boot 3.5 all the way to Boot 4.0, and the traffic light decision framework, green, yellow, or red for your project. If, thi- if this video saved you time, please hit the like button. It genuinely helps the channel grow and reach more developers who need this content. Hit subscribe if you want more Spring Boot Java and backend architecture content every week. Thanks for watching.